this is A, B, C and D. A is a full repository, B is also full repository, C is a partial repository, and D is a partial repository queue managers. So we are going to create two queues, two local queues in every queue manager in a cluster, and A, B, C, D are the clusters, and the cluster name is you can say alpha. Now we will create the queue managers for the full repository queue. Okay. So we'll define the objects of the A queue manager. So we will display we are going to create A and B as a full repository queue manager. So we will first check the attributes of a queue manager. So to create the queue manager A as a full repository queue manager, we have to change the attribute repos to the name of the cluster. So we are using the alpha as a cluster name, so we'll change the attributes of the queue manager with the alter command. In the same way we have to do in B also. So we will define the attributes of the A queue manager now. Okay, it's not fixed, right? I define no fixed, not fixed. So the queue is created in the same way. I have to define the another queue. This is called Q2. The same way we have to define the queue local. The local queues for the B also. So define queue local Q1. We have to give the same queue names in all the queue managers if we want to consider the queue in a clustering or in a cluster of a queue managers. Bind So we have defined two local queues for both A and B. Now for the queue manager C and D, these are the partial repository queue manager. So we do not want to, so we will not change the attribute of the repose attributes of queue C and D. So in the same way we will define the local queue for the both C and D. So define local queue define so in the same way we will define the Q2. If we will not define the Q2 here, only one queue will present in the C queue manager will be in the cluster. So we are considering two queues in all the queue managers. In the same way, this is a partial repository queue manager. Now that all the queues are created, all the queue managers, now we will define the receiver channel. So the receiver channel is a channel. We will define only one receiver channel for all the queue managers. It means that we will define one receiver channel for all the queue managers to retrieve the message. So to define the channel, the command is define channel name. So you can give 2.a channel type is a cluster receiver channel, so it will be CLUS RC VR. Connection name, it's a local system, so I'm defining a local host, and the port number I'm giving for A queue manager, I'm defining 3131 port number, for B 3232, for C 3333, and D 3434. So channel got created. In the same way, we have to define the receiver channel for B. Define channel. The name of the channel is like 2.b channel type. The port number we are defining for B is 3232. And the cluster name. So we define a channel for partial queue manager C. port number we are giving for 3333. And 3434 is a port number for the DQ manager. Now we will define the sender channel. Now C and D are the partial repository which will communicate. The C will communicate to A and D will communicate to B, and also A will communicate to B and B will communicate to A. So in the same manner we have to define the sender channel. So define channel. So it will communicate to the second queue manager, means B queue manager. So 2.b channel type says dr con name name will be a local host. If you are using a remote system, then you have to provide the IP address over there. And the port number we have to give this port number. So this port number is 3232. Cluster so channel got created. It will communicate, this will communicate to this one. and the B will communicate to A. So we have to define a center channel for the B also. Define channel name like 2.A, channel type will be a cluster center channel, so CLUS SDR, and con name. So in a con name we have to give an IP address of this one if you are using a remote session. As we are using a source local host, so we will give the local host name as a name. So you have to give a port number. So the port number you have defined for this is 3030. And the cluster name. So now C will communicate to A and D will communicate to B. So in the C we have to define a center channel which will communicate to A, and D will define a center channel will communicate to the B. A channel type so it will be 323 and cluster I. Now we will define the listener. So we will define the listener for A, B, C and D. So define listener a.lstr type TCP port number. So the port number will be 3131. So listener got created. So we have created all the objects of all the queue managers. Now we will start the listener. So now we will start the listeners of all the queue managers. So start listener. In the distribution setup we have to start the channel also, but in that clustering the channel will be started automatically. So listener will start. So let's run. So all the listeners are up and running. Now we will put the message from a queue manager on the local queue, and we will check how the load balancing will be done in the cluster. So we will give, for example, Q1, and we will give the queue manager. So we have put some more than 20, 23, 24 messages. Now we will check the load balancing happening or not. So see, in Q1 there are 8 messages, 7 messages, so in C we don't have a message. D also we have methyl. So some issues with the C, we have to check it. Okay, so we have to alter the repos. See, the spelling is correct. It should be alpha, right? I get to know this issue because when I opened the MQ Explorer, I saw the B is a full repository and A is a partial repository. So we have to make it sure that it should be a full repository. So alter QMGR repos to alpha. Sure, it is alpha. We will check here also. So is it good? It's a alpha. Is it alpha here? So in the same way, I will check the attributes of all the channels. So it's alpha. It's alpha. It's also alpha. So now we will check it. So A has become a full repository, that's correct. C and D are partial repository, as you can see in the MQ scroll. Now first we will take the message out from the B, C and D queue to D queue managers. Queues. So the current depth is 7. It's 8. So we don't have a but the message is not processing to C. Some issues. Let's see, first we will remove the message from A, B and D. So and Q S get get. So we have to give the Q1 and the Q manager in visit. So 1 4. See, the load balancing is happening, right? 1 4 7, and the load balancing will be happen as per the round robin algorithm. And also we have to define at least 2 full repository queue managers as per the IBM recommendation. So we'll check how many. This is A, right? This is A, so we will check for the A queues. So this is current equal 0. The same we will get all the messages from the B and D also. So we take the message from B also. So we get the message from the D also. Oops, sorry, we don't have a message in C, right? So no message will be there in C. So we not to take receiving any message. So we will put some message in Q1 again, and we will check the load balancing happening to the A, B, C, and D. So QS PUT Q1, and the A is a queue manager. So the same way we are putting A, B, C, D, E, F, G, H, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. So we have put 26 messages from A queue manager, and we will check the current depth of all the queues in every queue manager. So you can see there are 7 messages in queue of A, six messages in C, 6 messages in D, and 7 messages in C. So 7 7 14 and 6 6 12. So it's 26. So this is how the load balancing happen in the cluster. In the same way, we can put the message in Q2 also. So AMQ is this one, or what we will do, we will not put the message from this queue manager, we will put the message from B queue manager. So Q2 and the queue manager is B. So here we will put some 26 messages in the QB queue manager. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 sorry 20 21 22 23 24 25 and 26. Something I have missed here, not an issue. That's not in the increasing order or the ascending order. Anyway, we can see the messages. So from the B we have put the messages. So it will the load balancing will be happen to the A, C, and D. So in A queue manager we have 7 messages. In Q2 7 messages in Q2 of B also. 6 messages in C and 6 messages will be in D. 7 messages in Q2 D. So we have put 27 messages, it means. So now we will first retrieve the messages and I will show you how to put the message in the queue manager C. So first we will retrieve the message AMQS GT Q2 C. So you can see here the message are in 8, 4, 8, 12, 16, 26. So it's a round robin fashion. The first message will be here, second, third and fourth. This is B, right? Okay, Q2 B and Q plus GET. This is Q2 and this is D. Q2 and D. So we have written all the messages. So we can see. So the curl depth is it will be 0. It's taking time. So it's 0. So we'll check one by one. This is 0 in Q2. We have received a message from Q2, right? Then 0 0 and we have missed, right? Okay, this one 0. Now we'll put the message from a partial repository queue manager, that is from C. So the same way AMQS T Q2 and this is C. So we'll put some messages from this one. So we will put like Q W E R T Y U I O P A S D F G H J K L Z X C V B and M. So again I have put 26 messages from C queue manager. This is a parts of repository queue manager, and we will check the C. The messages are retrieving from the C queue manager. So from the C queue, the queue of C queue manager. Okay, it's now 7, as you can see here in the start from this beginning. Sure. This is 6. So 6 here, 6 here, 7, and the last will be 7. So this is how clustering is done. The load balancing is done in the clusters of in the MQ. So I hope you liked the video, and in the next class I will discuss about in the distribution setup along with the clustering. Thank you.